So in this lesson, I'm going to be explaining how to predict the products for a double replacement reaction. And so as a quick review, I'm going to show you just a generic double replacement reaction. So in a double replacement reaction, if you have element A paired with element B, they're going to react with another compound. Let's call it element CD. And what's going to happen is you are going to have a complete switching of partners. All right, and so here's where this matters, and this is the kind of the nuance of it. Before, we just saw that they switched partners and we called it a day. Now we really need to understand what is going on here. So in a double replacement reaction, the first element is going to always be positively charged in that compound. The second element is always negatively charged. Again, here, positively charged followed by a negatively charged ion. So when we switch partners, what actually happens is that this element here, element A, is going to combine with element D because a positively charged ion will always be paired with a negatively charged ion. So it's going to form a new compound, and that compound is going to be AD in that order. And in order to create that compound, just like what we do here in creating these ionic compounds, we need to cross our charges. So I call this outies. These are my outies. All right, so I combine my outies together, and then I'm also going to combine my innies together. So my innies in this case are going to be C and B in that order, because remember, a positively charged ion is going to go before a negatively charged ion. So C and B are going to go together. So I've got C followed by B. And when I'm creating all of these ionic compounds, I need to be crossing my charges. Okay? So we're going to look at a couple of examples right here, both for what we call precipitation reactions, which I'll explain in the next section, and also an acid-base reacting together. Those two types, so both a precipitation reaction and an acid-base reaction, those are both types of double replacement reactions. So let's look at a couple of examples here, keeping these rules in mind. So to begin with, I give you your two different reactants. So we first have to write the formulas for these reactants, all right? So we've got cadmium 3-phosphate. So in order to write that formula, I've got to cross my charges. So I've got CD, and CD has a 3+ charge. And then I have phosphate, which is PO4, and it has a 3- charge. And so when I cross my charges, these 3's will actually cancel. And so what that will give me for my first reactant is CdPO4. That is my first reactant. All right. So that's going to react with my second reactant is ammonium sulfide. So the formula for ammonium is NH4, and it has a +1 charge. Okay. And then sulfide is S, and it has a 2- charge. All right. And if you need help with those charges, go back in a previous video and I explain how to determine the charge for single ions like sulfide, or memorizing or using your chart to see your polyatomic ions. All right. So I'm going to cross my charges here. And so what I end up getting, the 2 becomes a subscript for NH4. So I've got to put NH4 in parentheses because I've got 2 of them total. So it's going to be NH4 subscript 2. And then just S because we don't include the 1 right here. All right, so those are my 2 reactants. And so for a double replacement reaction, what we do is we do innies and outies. So my outies here are going to be cadmium and sulfur. So I'm going to combine those 2 elements together. And as far as order is concerned, remember, you always write a positively charged ion before a negatively charged ion. So I'm going to have the cadmium go before the sulfur. Okay, so those are my outies. And then my innies are going to be ammonium and phosphate. Okay, so it's going to go ammonium first because it's positively charged, followed by phosphate, which is negatively charged. So let me show my crossing of charges here. So cadmium, we had said, has a 3+ charge. Okay, sulfur has a 2- charge. And so when I cross my charges, this is going to become CD2. The 2 comes from the sulfur. S3, the 3 comes from cadmium's charge. Okay, plus I now need to cross the charges for ammonium and phosphate. So ammonium, remember, has a 1+ charge, and phosphate has a 3- charge. All right, so when I cross my charges, the 3 goes to the ammonium. So I'm going to put ammonium in parentheses. It's going to be a 3. And then I've got phosphate, and I only have one phosphate, so I'm not going to put it in parentheses. You can if you want to, but you don't need to because there's only one of them. Now the last thing I need to do is I need to balance. So the way that I'm going to do that, I notice I have 2 cadmiums here. I only have one on my reactant side, so I'm going to put a 2 in front here. All right, that gives me 2 phosphates, 2 PO4s, so I'm going to put a 2 in front of ammonium phosphate now. Now I have 6 ammoniums. I only have 2 on my reactant side, so I'm going to put a 3 in front here. Then that gives me 3 sulfurs, and I have 3 sulfurs here, so I'm good to go. All right, let's look at the next one. All right, for aluminum sulfate, I need to cross my charges again. So aluminum has a 3+ charge, okay? Sulfate has a 2- charge. Okay, so when I cross my charges, what I end up getting is Al. This is going to be a subscript 2 coming from sulfate. SO4 needs to go in parentheses because I'm going to have 3 of them because of the charge of aluminum when I cross my charges. Okay, so my other reactant is going to be calcium phosphate. So calcium has a 2+ charge. Okay, phosphate, as we noted before, has a 3- charge. So when I cross my charges here, that's going to become Ca3, subscript 3, in parentheses PO4, 2. Okay, so again, innies and outies. So for here, my outies are aluminum and phosphate, and aluminum is going to go before phosphate because aluminum is positively charged. Okay, and for my other one, it's going to be calcium and sulfate. Calcium going first because it is positively charged. Okay, so I'm going to cross aluminum and phosphate. Aluminum has a 3+ charge, okay? And phosphate has a 3- charge, so notice those charges are actually going to cancel each other out. And so the formula that I end up getting is just AlPO4, okay? And my other products are going to be calcium with sulfate. Well, calcium has a 2+ charge, right? Sulfate has a 2- charge. So notice these charges are also going to cancel once I cross my charges, the 2 going there, the 2 going there. So I'm going to end up with CaSO4. Now the last thing that I need to do is I need to balance. So I've got 2 aluminums on my reactant side. I only have 1 on my product side, so I'm going to put a 2 in front here. That gives me 2 phosphates on my reactant side. I'm good. I've got 3 sulfates, 3 SO4s, which means I need to put a 3 in front of CaSO4. Then I've got 3 calciums, and I'm good to go again. Last one, copper 2 sulfide reacts with potassium chloride. So here I give you the charge of copper because it is one of our metals whose charges I don't know because it's a transition metal, so that's 2+. Sulfur is a 2- charge looking on the periodic table. So when you cross your charges, they cancel. So you just have CaS, and that reacts with potassium chloride. So potassium has a 1+ charge. Chloride Cl has a 1- charge. You get those by just looking at the periodic table. And I get KCl. So nice and easy, no polyatomic ions here. Again, I need to do my innies and my outies. So calcium is going to combine with chlorine because those are my outies. Calcium is going to go first because it's positively charged. Okay, and then I have potassium is going to be my innie, sulfur is going to be my innie, so potassium with sulfide. So now all I have to do is I have to cross my charges. Okay, so calcium has a 2+ charge. Chlorine has a 1- charge. So when you cross your charges, you end up with just CaCl2. The 2 came from the charge of calcium. For your other product, you've got calcium, which has a 1+ charge, right? You've got chlorine. You've got sulfur, which has a 2- charge. So when you cross your charges here, you get K2S. All right, so now I'm going to balance. I've got 1 calcium, 1 sulfur, 1 potassium on my reactant side, 2 on my product side, so I'm going to put a 2 here. That gives me 2 chlorines, and I am balanced. All right, so I'm going to really quickly, before we get into writing the reactions between acids and bases, I'm going to quickly explain how to name and write the formulas for acids. Now, there are 2 different acids that we'll be looking at. Acids that simply have 2 elements, so for example, HCl or HBr or HI, right, where you have the hydrogen and then 1 anion. and then acids that have 3 elements. So that would be an acid that has a polyatomic ion. So let's first look at the acids that have 2 elements. So the way that we know an acid only has 2 elements is that the acid's name starts with hydro. Okay, so what you do is you would write hydro, then you put the stem of the name of the anion followed by ic. So for example, for hydrochloric acid, HCl, we know it's HCl because it's hydro, meaning you only are going to have one anion. Chlor is the stem for chlorine, and then you add the ic ending. So hydrochloric acid would be HCl. Hydrobromic acid would be HBr. Hydroiodic acid would be HI. Hydrofluoric acid would be HF, etc., etc. All right. Now, if instead of 2 elements you have 3, you have hydrogen and then a polyatomic ion, the rule is the following. If the polyatomic ion has an ATE ending, so sulfate, nitrate, carbonate, what you do is you simply write the stem of the polyatomic ion. So for this example, for nitrate, it would be nit, and then you add an ic ending. So it would be nitric acid would be HNO3 because NO3 is nitrate. However, if you have the polyatomic ion that has an ITE ending, like nitrite here, you take the stem of the name, the exact same as before, but instead of ic, you have us. So this would be nitrous acid. All right. The way that my students helped to remember this, again, I apologize, this is students who remembered it this way, but they said if it is just us, it is all right, or ite. If it is 8 of us, it is ic, which I think is really applicable now that we have COVID right now, but this was pre-COVID idea. All right, so if it's just us, it's ite. If it's 8 of us, ic. All right, so whenever you're writing the formulas for these acids, you need to be crossing charges. So for HCl, hydrogen has a +1 charge, chlorine is -1, that's why it's HCl. For nitric acid, hydrogen has a +1 charge, nitrate has a -1 charge. I cross my charges. Let's look at some other examples here. So for example 1 here, phosphorus acid. So I know I'm going to have hydrogen because all of my acids are going to begin with hydrogen in this class. Okay, it has a +1 charge. Phosphorus acid, the us tells us that it's going to be an ITE ending. So phosphite, the formula for phosphite is PO3 So when I cross my charges then, the 3 becomes the subscript for hydrogen. So this is simply going to become H3PO3 and I am done. All right. So the hardest thing is just remembering what goes with what. All right, for the next one, hydroiodic acid. So I see a hydro here. I see an ic ending. So that tells me that I am only going to have 2 elements. I'm going to have my hydrogen, which again has a +1 charge. And then iode comes from iodine. So it's going to be I with a -1 charge. So when I cross my charges here, I got HI. And again, we know that simply because hydro is at the beginning, so that tells me I only have 2 elements. Sulfurous acid here, all right. Again, if it were sulfuric acid, that would be SO4, but because it's sulfurous acid, that's going to be SO3 because that's sulfite rather than sulfate. So hydrogen has a +1 charge, sulfite is SO3 2-, so then what I'm going to do is I'm going to cross my charges, and this is going to become H2SO3. And that's the formula for this acid. All right. Okay. For the next one, let's start writing names now. I've got H2CO3. So I've got 3 elements here. So I'm in this situation right here. This is going to be a polyatomic ion. CO3 is one of my polyatomic ions. It's carbonate. So since I have an ATE ending, that means my acid needs an ic ending. So I'm going to take the stem of my polyatomic ion, which is carbon. So it's going to be carbonic or carbonic also with the correct pronunciation. So the name of this is going to be carbonic acid. All right. And that's all there is to it. For the next one, if you look, I'm going to jump ahead as I write slowly. HF. I've got 2 elements here. Fluorine is my anion. So I know that this is going to start with hydro because I only have 2 elements. So this is going to be hydro. Then I need the stem of fluorine. So this is going to be fluor. And then I need an ic ending. So it's going to be hydrofluoric acid. All right. All right, let's look at the last one. So I've got HClO. I've got 3 different elements. So I know that ClO is a polyatomic ion. ClO, remember, is hypochlorite. So since it's an ITE ending, that means that the acid is going to need an us ending. So this is going to be hypochlorous, because remember the ite becomes an us, so hypochlorous acid, and that's it. All right, so now what we're going to do, I'm going to have you guys look at acid-base reactions, now being able to write the formulas for these acids. All right, well, what if I have a double replacement reaction and it is between a base and an acid? Well, it's going to look just like what we just did, which was showing your reactants, having innies and outies combined together, and when you're creating your new product, crossing your charges. So calcium hydroxide, I've got to write the formula. I know this is a base because it has hydroxide, but calcium has a 2+ charge. Hydroxide has a 1- charge. I'm going to cross my charges to form this. When I cross my charges, I get CaOH2. Okay. Your other reactant here is hydrobromic acid, HBr. Hydro, remember, tells you that you only have a single anion. It's not a polyatomic ion, so it's just going to be HBr when you cross your charges, +1 and -1 for bromine. So there's your acid there. Okay, so HBr. And now I got to switch partners, right? So innies and outies, exact same thing as what we did before, even though it's an acid-base reaction. So calcium is going to combine with bromine because those are my outies. Okay, and my innies here are going to be hydrogen and OH. Okay, so just because there are 2 hydroxides here, don't let that freak you out. You're only combining hydrogen and hydroxide, all right? So for this problem, calcium, as we noted before, it has a 2+ charge. Bromine has a 1- charge. So when you cross your charges, this is going to become CaBr2. Okay, so there's one product. Your other product is going to be what results from hydrogen, which has a +1 charge, crossing with hydroxide, which has a 1- charge. So notice when you cross your charges, this would just give you HOH. Another way of saying HOH, and the correct way of saying it, is simply H2O. So when you have an acid and a base reacting together, you're going to form a salt. And remember, a salt is any ionic compound. It is not just NaCl and water. Now I have to balance. I've got 2 bromines here, so I immediately know that I'm going to have to put a 2 in front here. That'll make my balancing of hydrogens easier. That's why I jumped at that opportunity. I've got 2 hydrogens here, 2 hydrogens here, which gives me a total of 4 for my reactants, which means I need a 2 in front of water. Then I've got 2 oxygens here, 2 oxygens here, 1 calcium, and I am balanced.